the book that I wrote, or all the words that we spoke, yet only with our eyes. Now is the time to choose. Somebody wins and some lose. I can see through your disguise. Lay down, hope for something better. Looking at the clouds, deciphering the weather. You can't keep this up. The lies are just too much. Kick back, start another fire. Looking at the clouds, making shapes that you admire. And you can't stop it now, 'cause you don't know how. You can't stop it now. open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move.
Yeah. Hello, everyone. Hey, how's it going? Can everybody hear me all right? All right. So, welcome to NDev. This month, we're going to be talking about real-time collaboration with Firebase. Mike Burton of GameDev and Celtx.
No longer
associated, adjacent to
Jason,
GameDev
a member of.
member of GameDev and at Celtx here in town. We'll be talking about Firebase. Cool. Without much ado, I'm going to go turn the mic up a little bit more and get the mic. Thank you, bud. A lot of mics.
There's a reason why I have no water. All right. So apologies for my voice. I've been doing renos for like 2 days, so maybe a little raspy here. So, real-time collaboration with Firebase. How many people have done real-time collaboration? How many people have worked with Firebase? Hey! All right. So, Firebase was a company once upon a time. Now they're part of Google. And they do some cool stuff. They do basically real-time messaging, communication. They give you a really rich WebSocket layer that kind of does bespoke storage and a bunch of other fun stuff. Firebase is not, as we originally thought at Celtx, just the real-time database. It is an entire platform. It involves metrics, analytics. It's got a real-time database, but it's also got another product that we'll talk about in a bit. So I'm Mike Burton. I'm a senior dev at Celtx. I'm the primary for real-time collaboration at Celtx. Celtx is a script writing company, so we offer multiple rich text editors, basically on the web, which is a harder problem than it sounds like. And in particular, real-time collaboration in rich text is kind of hard because you're using fairly sophisticated schema documents, and you then have to provide the editing model in a way that is compatible with, the modern standard of real-time collaboration, which is sort of not having any of the buffoonery of people overwriting data most of the time. So real-time collaboration is just basically two users editing the same document at the same time. This is useful especially in creative industries where you have people, and in academia actually, is the other one where you see a lot of people pushing this kind of activity. Of course, it's been done via databases for most of the century now. Optimistic and pessimistic blocking were the original real-time collaboration. That eventually blossomed into server-side triggers, and then people kind of said there's got to be a better way. So Firebase and a few other platforms came along. And this is the problem that they hit almost immediately. So the two generals problem, how many people have heard of this? So the two generals problem is basically, how do I know that you know what I know? And so I send you a message, and you say, I got your message. And I say, I got your message that you got my message. And you say, I got your message that you got my message that I got your message. So the problem with that is there is never a point where we have perfect confidence that everybody knows the state of the world, right? Two generals is a reference to kind of the metaphor of two generals saying, I'm going to go to this town and attack at sunrise. And, so one guy says, I'm going. And the other guy says, I'm going too. And the other guy says, okay, so we'll both go there. And then the other guy says, okay, so we're going. But they can never be absolutely sure that everybody is committed to actually going. And in networking terms, this turns into the TCP protocol, right? We kind of give up after a while. We go SYN, we go ACK, we go SYN-ACK, and then we just say, whatever, I don't care. I know, this is the first computer communication problem that was proved to be unsolvable. There is no formal solution that works for this. So you have to do your math differently when you're trying to edit something in a way that is consistent. So let's talk a little bit about data models for doing that. There are two big ones. Operational transform. Operational transform was not created to blow my ears out. It was primarily popularized by Google. And for those of you who are old like me, you'll remember Wave. So once upon a time, Google created a multi-threaded messaging / rich editor called Wave that they never really figured out what to do with. But it eventually got adopted by Apache, and as of last year, it's been retired completely. Because there are more interesting things happening. But the white papers from Wave are actually where most of the operational transform thinking came from. Recently, there's been an advance called conflict-free replicated data types. So those are a fairly different solution. Unfortunately, most of the fairly different solutions in this space eventually end up looking almost exactly the same. So we'll talk a little bit about that as we get into this talk. So operational transformation in particular focuses on operations. There are two key properties that any OT algorithm has to sustain. One is causality preservation, which just basically means, if I'm going to do something, then that is going to happen in all documents. And convergence, which means at the end of the day, we have the same state, which is sort of the eventual consistency model of the world. Operations are context dependent, which just basically means if I do something at position A and do something at position B, I should consider them to be different operations. They can be inclusive or exclusive, which just basically differentiates between how I accommodate conflicting operations. So if I insert a position 3 and you insert a position 3, inclusive says I'm going to keep both, exclusive says I'm going to throw one away. Those are implementation choices in this space. OT has the funny property that a lot of the implementations are not actually OT. People get this wrong a lot, and in particular, they don't guarantee convergence, which completely blows away the point of doing real-time collaboration in the first place. Convergence just, again, it's about the end state. So if your end states are different on two different clients, you're not really doing OT. You're not doing anything that's recognizably real-time collaboration. You're just sending data. So one example, Google and Apache Wave, depending on what point in history you enter the stream. There's this nice white paper called Google Wave Operational Transformation, and they talk about state transitions, and in particular the state space. So you can see, you come down the client side here. A direct path would be 4 client transitions. A direct path would be 4 server transitions. But these guys can apply these in different orders. And as long as we end up at the same point periodically, we're going to be okay. So we send a transformation from the client, or we process a transformation to the client, then we receive one from the server, and we end up at this space, right? So C here and S prime is the same as S plus C prime. So the OT in there is how you get from S to S prime and C to C prime. That transformation is all about the mapping of those so that you have that consistent endpoint. So we'll talk a little bit about that later on, but basically the notion is that you either support a mapping from one operation to another, or you can invert, right? So you invert and apply. And how you do that is very implementation dependent. There are a lot of different options for how to do that. But the fundamental theory is that you're going to end up at the same place. So all of your choices need to guarantee that. The other main approach that's used today is called conflict-free replicated data types. So conflict-free replicated data types, they focus on states rather than operations. And there are commutative and convergent RDTs. So commutative basically means no matter how I apply my state changes, they're going to work out the same way. And that involves a fairly large amount of state design, essentially. Convergent focus more on the actual operation itself. So I design my operations such that I can gradually coax them into the same condition. There are a lot of different approaches. And I've just listed some of the basic ones here. So a G set is an add-only set. As you can imagine, that is not a particularly challenging target to hit for getting a consistent state. I added something. Okay, I added something else. I added the same thing. Okay, now we have the first 2 things. That's a G set. That is the topic of someone's PhD somewhere. Anyway, the next one is an OR set, which is an observe and replicate set, I think. And basically what that says is, or observe and remove set, sorry. So an OR set basically gives you the option of removing an element from the set. So at some point someone can tag something as removed and it will no longer be in the set, which is a huge advance over a G set, which is you can't remove it all. And then LWW sets will be familiar to anyone who's done a lot of database work. It's last writer wins. So you involve timestamps. So slowly what we do is we build up these models of sets and set-like objects that give us the behaviors that we want. So, for example, an OR set typically has 2 G sets. One is for the added items, one's for the removed items. And merge those two together and put them through what's called a lookup or a reduce step. And we say, okay, I've got all these, and I've removed these. So the sum of those operations ends up being my final lookup state. So that first step, that merge, is saying, give me all your states from all of your clients. And the second one is, give me the lookup after I've merged all of those states together. And we'll actually get into that in the demo a bit later. So here's the CRDT implementation. These guys did a nice little talk at Lambda Days in 2016. Dimitri and I don't remember the other guy's name. So NavCloud was looking to figure out how to get favorites to work in this way. And so they have a fairly rich favorite notion, and they don't actually use it for this demo, but they're just trying to get the notion of what does it look like when we actually support last writer wins. And they in addition, they wanted, so the OUR set is actually more like a last writer wins plus a timestamp, or plus an ID, sorry. So it supports an update step, which is what the U is there. So you can see if client A is adding, or is removing a cat, removing a dog, and client B is adding a tiger, adding a dog, adding an ape. We can go down to the merge, and we have these unique items. So as an example, we have the dog removed, right, at time step 2, but it was added at time step 1, so the remove wins, and it does not appear in the final lookup combined state, which I thought was a pretty neat way to illustrate how simple this can be. Having said that, it's hard to see how that applies to something like text editing. But once you get into the notion of a positional index as well, you can really start to do some interesting things. So that ID, imagine adding a time step and an index into your document or whatever, your data set. And you can really start to compose this into something very interesting. So let's talk about Firebase for a minute. Firebase, like I said, started as a real-time database project that launched in 2013. They were just a random company in the Valley. Google acquired them the next year. So yeah, it's something good. And then in the last few years, Google's been developing the successor to the real-time database called Firestore. So Firestore is meant to be a full-fledged replacement for a real-time database in most situations. There are still situations where a real-time database can be cheaper, where it can be easier to manage. If you have particular kinds of experience, it can be simpler because it uses a fairly traditional sharding strategy for data, those kinds of things. But Firestore is meant to basically get all of that out of your wheelhouse and make scaling, data management, and real-time communication all happen in the same place. So Firestore also came out of beta on January 31st, so it's not necessarily the world's most mature technology, but it is pretty good at this point. Real-time database, I want to actually show you what it looks like. So it's a JSON-like data tree. We hit this actually. It limits you to 32 levels on that tree, which is not much. It's really, really easy to hit that. And their recommendation for fixing that is make your data more shallow. So you end up having multiple trees to represent a single document. They also limit you to 100,000 connections, which is great until you scale beyond a certain point. You have pretty restricted querying capability in real-time database, and they're always deep. So if you hit the wrong target in this tree, you can imagine you can be pushing a lot of data over the wire. And all these solutions, Dynamo, Real-Time Database, Firestore, they all tie some of your cost to how much data you're pushing. And especially if you're doing lambdas, cloud functions, that kind of stuff, it very quickly gets expensive to do it. So they have a strong design recommendation for shallow data, so that you're not pulling a lot of data all the time. At this point, it's only recommended situationally, and the reason for that is Firestore. But before we get into that, I just want to show you if I come into my little Firebase console, and anyone can access this, by the way. I just set this up today. I have no idea if it would even work, but there are two. So their database now supports two different options. There's the Cloud Firestore and the Real-Time Database. So if I go into a Real-Time Database, it starts off as a null node. I can add myself a root node. Then I can add myself a child node. And I can add myself a field. And I can just add a value. So pretty simple to manipulate, extremely simple to work with, very nice to start with. And that's as opposed to the Firestore model of the world, which is start with a collection. So I'm just going to call my collection collection. And so immediately a collection is a set of documents, right? So if I just create my document and just hit save, now I have my collection and my document. I can add a field to it, which is just a value. But I can add some rich data in there as well. So there's some cool things you can do here, like you can add a map. So if I add my map data in here, then map child, and that can be a map. So I can go many layers deep in a field, and a field is not a first-class construct in here. A field is a kind of data, right? If you persist by default a JSON object to Firestore, it's going to create it as a map type field. So you have to be really careful how you construct your schema in Firestore. In particular, if you've done any NoSQL work, you hit a hard limit of 1 megabyte per cell, right? Dynamo has that limit. A bunch of other systems have that limit. I don't know if Dynamo still has that limit, but I think so. We'll say it does. Most NoSQL systems set a hard limit on how big your cell can be. You have to shard your data across it. So if you have tree structured data like we do, you need to figure out what are going to be collections and documents, right? And then I just call this a field. Just want to get onto. So I can also add a collection to a document. So they call these sub collections, but there's really no difference. Subdoc. And subfield. So then you start getting into layers of implementation here. And so, Firestore requires you to actually know what you're doing. That's the difference. Like, I can just serialize JSON to real-time database and forget about it. I can basically make that data as big as I want to make it, and it's not going to do too much damage. Well, with Firestore,
Finish thought.
What?
I was going to say.
Oh, with Firestore, you really want to make sure that you have your first-class constructs as nodes in there, and of course, anything that's an array should have collection type. But sometimes you're also going to have just a subtree that has a lot of data within it, and you should make that a collection as well.
This collection, document, subcollection, subdocument, does that go arbitrarily deep, or is that 32 as well?
No, that's. I think there is a limit, but it's like 100 levels. And of course, you can put maps within maps within maps.
Right.
So if you're doing 100 to the power of whatever, you know, I guess you've got bigger problems than how deep the map goes.
Cool. Thanks.
Yeah, and these guys, this doesn't have any of the connection limits. It doesn't have the real difficulty with this is structuring your data. Yo,
Could you expand a little bit on what a map is in this context?
so a map. Let's go back up. A map is just basically what most people are familiar with as the kind of data that's used for JavaScript, for Python, a simple object, right? A bare object that just has data within it. So you have keyed fields, right? So if I go in and I want to add a new key to this field, I just add a name and value. And a map can contain other maps. It can contain all kinds of rich data. But fundamentally, it is simply a structured object in the same sense that most modern languages support. So, I mean, I think Python does bare objects, JavaScript.
Dictionaries.
Dictionaries, sure. Yeah, I mean,
Gotta be different.
well, I think a lot of people probably call them dictionaries, even Visual Basic. Like, I'm old, sorry. But yeah, maps are fundamentally also known as collections, as dictionaries, as indexed lists. So, but they all do the same thing. They give you the ability to add keyed data, right? And again, this whole set of fields has to be less than a megabyte. So you really need to be careful about how you persist that data. The nice thing about Firestore is queries are shallow by default, so you don't have to do things like what I was doing for our cloud functions for the real-time database. Remember, queries are always deep here, so I would have to actually run through the REST interface from a cloud function, which is the only way to access real-time database in a shallow way. So even though I have, a document that has 400 megabytes of data in it, I have no way of accessing a sub-collection of that unless I've organized it correctly up front, unless I go through the REST interface. That's not a concern with Firestore. Moreover, it supports fairly rich query syntax, so I can do things like where a particular field is equal to, so I could do where mapchild.field equals field. And I can kind of get a lot of leverage out of that. So those are nice systems, and we've already talked a little bit about the data models that are in common use. I want to talk a little bit about what Celtx did and why we did it differently. Celtx implemented a layer called Prosemir, which is written by a guy named Marine Haverbeek. You might know him from CodeMirror. He wrote a text editing backend called Prosemir. It's not a text editor, it's just plumbing for a system like that. And he took the approach that he was going to use a centralized authority because this is meant for people writing text editors, not for Google rewriting docs or whatever. So a centralized authority gives you some nice characteristics because you can dependably and reliably recreate your order. So if we talk about in the SQL days, and I guess those are still here to some extent, pessimistic and optimistic blocking gave you implicit operational ordering, because if I was trying to send an update and I didn't already have that data, pessimistic block would say no, and optimistic block would say no, but, or yes, and, depending on the situation. Some of the older source control systems had the notion of a lock state. So they all relied on this notion that there's one authority where your state of the world lives. So Haverbeek went ahead and implemented what I'm going to call pseudo-OT. Pseudo-OT gives you authoritative ordering, so you don't need to guarantee that one thing, that causality preservation part of OT is no longer applicable. You can say, my operations are always going to be applied in the same order. So I don't need to worry about what order, whether they have that property. It can just be convergent as long as they're applied in the same order. Which sounds like a really simple thing, but then you get into the notion of a local operation. So a local operation is something I've done that hasn't yet made it to the server. And in text editing in particular, you need to invert those before you can apply the authoritative ordering. So you can imagine, I insert some text, I haven't sent it up to the server gets a new text, sends that back to me, I have to insert that text in its original condition. So I have to roll back all the changes I've made, and then insert the text that I received, and then remap my transactions and reapply them. So that can get fairly complicated once you get into a rich text editing structure, but it is kind of nice. This is the prose mirror. The core of prose mirror is this thing called receive transaction. I just kind of wanted to show you what it looks like in an implementation. So our state, prose mirror uses what's called an immutable state processing engine. So you get a state, you update it, you create a new state from those updates, and you never touch the original state. So we always get a state, apply some transforms, create a new version, return that. Nobody ever touches the original. Very, very easy to do that wrong in code, of course. So here we're just grabbing that state. We're looking at the version of the state. So the state here is a collab-specific state. What's the version number I'm on? How many steps are in that version? And, what's my ID? Then we move ahead and do some steps. So we look at that list that we just pulled out of that state, called the unconfirmed list, which is those local steps, right? So we slice that list and say, I don't want to process anything that's mine. I just want to ignore those. Those have already been applied. Then we go ahead and say, are there any other steps? And if there are, those belong to someone else. I need to do that remap and rebase activity. So the rebase is where the real magic happens. So you take your unconfirmed list, and you have to do this thing called a rebase. So a rebase is two operations. The first is invert every step that I have in my unconfirmed list, apply them to the state, apply the remote transactions, remap the unconfirmed list to using those received transactions, and then finally apply those remapped transactions. And at the end of all of that, we get this new state, right? Which is going to be the new document, the new version number, which is for this we use a simple ordering, which is an integer. We basically say, okay, I've applied all of these steps, so I'm going to add the number of steps I just applied to my last version. I'm going to apply my new unconfirmed, which should be nothing if I've done that correctly, and we end up with a new state. There are some problems with that approach, just in case you thought it'd be easy. It does sound really easy, right? I'm just going to take all my text editing steps, I'm going to turn them around, I'm going to undo all of them, which I have to do anyway, and then I'm going to do some stuff. But yeah, even if you get your undos right and your remaps right, there are still some problems that you need to think about. So with a naive approach, you end up with a long step list. So you start with a known base state, usually an empty document or one node in the document maybe, and you apply all the changes from the beginning. And that's great until you're writing a professional grade text editor, and then you get, a million steps that you need to apply every time someone loads the document. So that's really hard on your cost. It's really hard on your user who has to wait an hour for their document to load, all that fun stuff. So what you end up doing is you roll those up, right? You take your step list and you do a save. And you say, I'm going to save that out, and then I'm going to apply steps from there. So then the problem that you run into there is, how does the state and the step connect? So you start with that base state, you apply your changes, you roll up into a new base state, you apply changes to the new base state. How do you know which base state to start from? So you have to tie the number back to that, right? Which is fine. But then you get into save consistency, which is where my headache has been for the last 6 months. So the naive approach now is start with a known base state, apply some changes, roll up a new base state. Now I've got my step number, so I know if I load up again, I can just load up from step 100 forward. But you can't save your local changes to your base state because those are not valid steps. So there are two possible ways to solve that. One is just to do your save server side. That requires that you have a server that actually understands your editing engine. For some people that's worth it, for us it wasn't. So we went with a different approach, which was client-side transaction control. So we now require a fully committed step list on the client before we allow a save. So I can say, I'm going to push all my local changes, and I'm going to record that version of the document as soon as I know that that save was successful. And when that finalizes, when that whole operation is complete, then I can push a save. And I'm going to say, here's my step number, and my save is consistent, my step list is consistent, and they're tied together. Still hard. It's really hard, depending on how much other promisey stuff you're doing and how much async you're doing, but it actually works pretty well. I would recommend if you ever do implement something like this that you go with a server-side save, because you have a natural consistency, and it at least knows, the state of the document at any given moment. The problem is only that you have to know when to actually push a save up, and that's, I think anyone that's worked with a SQL database knows that can be tricky, because you don't want a state of the world that no one's ever seen, or at least that you don't want something that has some weird data condition that no one's ever seen, and that can happen pretty easily. So there's no silver bullet, sadly, but those are some of the things you should think about if you're implementing real-time collaboration. So let's do a quick demo here now. So if you have a laptop, that's good. If not, that's fine. So I created a really simple Firestore. Actually, I'll give a couple of people a moment. So I created a really simple Firestore implementation here. Top level collection is just called top. Then I have a document called test, and inside that I have a field called data. Right? Nothing complicated, nothing world shattering. So I'm gonna go out. This is my demo, and we all know how this goes. It's not gonna work, but we're gonna pretend it's gonna work anyway. So I'm gonna start from scratch. So I'm just gonna npm init this. Just going to accept defaults, basically. And then, so now I've got my npm, and I'm just going to install two packages. One is Firebase. Yep. Before I do that, I should install NDev, or save probably. So that's going to give me access to the actual Firebase SDK. Firebase includes a lot of tools. And there's some special stuff that we'll look at in a second about how you reference it in a production app. The other thing that I'm going to pull in is Don't look. Maybe I don't need it for this one. Okay. Yeah. Okay. So we're gonna say I don't need that for this one. All right. So now I've got access to Firebase. I'm just gonna go ahead and I'm gonna create myself a HTML file. Oh, I know what else I need. Parcel. npm install -save dev parcel. How many people have never touched Parcel before? You should. It's lovely. Parcel is one of the nicest bundlers I've worked with. It is what they call zero configuration by default, which just basically means it has a lot of opinions, but those opinions are meant to make you productive faster. You can still add pretty much any tool that you can think of. They have support for Babel, Browserify. I think they might have some Webpack stuff in there. But basically what Parcel does is it builds your stuff, it builds it in a more C++-like way, which is to say it does iterative building or incremental building. So it actually does CRC checks against the content of your file and date stamp checks, all that stuff. And it actually builds these incremental output files. So it doesn't have to rebuild everything every time that you run your build. I've talked about it before, but I'll talk about it again. So I'm using WebStorm, which gives me a nice little template here. I'm going to add one node, and I'm just going to add some text, and then I'm going to import a source tag script. C equals. And we're just going to call it demo.js. Nothing complicated. So now I'll get ahead, go in and actually add my demo.js. So first thing you want to do is import Firebase from, and this is where we get into that thing. So if I just do this, right, this is what they call test mode import of Firebase. And as of 5.0, which is a while ago now, Firebase switched to differentiate between test or dev and production mode. It's not hard to get in. You just add /app. But the full Firebase import has everything. And most of the time you don't need most of that. They have their stuff divided so that you import the base functionality, which is in the app namespace, and then you can just do their import of the rest of the stuff that you need. So in this case, we're going to import Firestore as well. So I'm going to put a demo down there, and then I'm going to define demo. So the first thing I want to do with this is I'm going to go Firebase.initializeApp, and I need a config for that. I'll deal with that in a second. So that app equals Firebase.initializeApp. And then Firebase actually allows you to create a ton of different applications on your local client. So you need to be able to differentiate between them, and the default way of doing that is just to use the application interface. And it's probably not actually called the application interface, but it's called something like that. And this initialize app actually returns it. So then I can go app.firestore, and that will give me the Firestore instance that is related to this specific application on the client. So, yeah, that's store equals that. And then if we want to hit that collection that I created called top, right? It's store.collections, and the collection is called top. So that's actually going to get me, if I just do this, that will actually get me what's called a query snapshot, which is the list of all of the docs that are in that collection. I'm not going to do that today. I'm actually going to go ahead and do doc My path for that is just test, and I'm going to do a get on that instead. So,
That, that get on the collection, that returns the document IDs or like the actual docs?
it returns what's called a query snapshot. So a query snapshot is an interface to the data.
Oh, okay.
It's not just like, you have to actually pull the data individually from each member. So query snapshot leads to document snapshots, and document snapshots give you access to the data via a data method. So if I look at that, I could do, let's say doc equals that, and then this doc is not actually, sorry. This doc is not actually the document yet, really. What you will want to do then is doc that data, right? And that will give you the bare object that the document refers to some extent. That'll give you most of the fields. It won't give you the sub-collections and all that stuff, right? So again, structure is important in Firestorm. So instead of doing that, I'm actually going to do doc on snapshot. And so on snapshot gives me access to the real-time updates from Firestorm. So I'm going to pull a snapshot from Firestore, and when I get it, I'm going to say, so now I need a reference to my element. So let e equals document dot query selector. Right? Nothing complicated there, I don't think. Does anyone not understand what I just said? Yeah. JavaScript, most popular language in the world, but there's always one guy.
What's the little bit that's off the screen?
Oh, that's the on snapshot. So on snapshot just gives me a reference to the listener, and I hand in a callback, right? So every time that callback is called, this listener function is actually going to get called. So now that I have my key element, I'm going to go key.innerText equals snapshot.data. And it's that simple. Because I have one document, dot data. Because data is going to give me the whole object. I just want the field called data. Right? So, if I've done this correctly, which is almost guaranteed now I do this.
Braces after on snapshot?
No. This is what's called an arrow function or a lambda. So I'm writing in ES6 style.
Oh, so you can just give it a name.
I'm actually handing in a closure, right? So this function actually preserves. So there's some nice semantics to this. Paul did a nice talk about it a while ago. Closures give you access to the actual this of your current context. So you don't have to worry about things like rebinding, which traditional JavaScript functions do. And those are very, very powerful. I recommend getting used to them because they're coming more and more into all the browsers. Your Babel layer right now probably compiles them away when they shouldn't anymore. But yeah, getting used to that syntax. It's not always good. Mocha, in particular, is a terrible place to use closure functions, arrow functions, because they do hold style binding. But most places are nice to use.
And your IDE is picking up the selectors, collection path, all the gray text. Is it?
Yeah. Yeah. This is the help of the web storm. It's great, but it also clutters up the screens.
And it's not actually there.
It's not actually there. That's just. Do you remember? Do you remember what this is called? This is what this parameter is called. Hey guys, it's like clipping. Sometimes clipping is good, not very often. You can turn that off, but I usually don't because.
I've never seen it. It's a neat feature.
it is, yeah, I like it most of the time. Like I said, I don't turn it off because I do find it helpful. I work in a lot of new interface SDKs, right? So, and even the Firebase one evolves every minor release. Is dog's breakfast of different things happening. So this is an async function. What am I doing? I don't need this equals anymore. I'm just doing on snapshot. I don't need this to be async, actually. So, just a reminder, this is what our index does. It just pulls in demo.js. Demo just calls itself basically at the end. And yeah, so let's take a look at what that looks like. So, if I just do parcel index.html, that should stand me up a server with built code. So it's a shotgun reloader, it's a builder, it's an incremental rebuilder. There are reasons why I like parcel. And I don't work for them. I just really like them. So here's my fun content. I'm just gonna pull this over to one side. And, oh, hold on. So, one thing I forgot. Not my config. Thank you, Michael. So, this config currently is nothing. So Firebase says that's not a thing. All right. So it's pretty simple to get that though. So first class construct in here, we just go into project settings, okay, and you use one config for everything. So you can just basically pull this code as is, stick it into your project, and you're done. Right? Like it's the simplest possible version of this activity. So now I have a connected application. So that'll reload, rebuild. Theoretically, it'll hot reload in the browser. So now I have my hello world instead of my empty, right? So if I look back at my code, it's set to somewhere in here. Oh, in index.html, right? It's hard coded to empty. So it's already picking up. That's all the code you need to pick up data in a real-time fashion, right? Which is nice. And then I can go one better. I can pull this tab out, and eventually, when I stop fat fingering, I can go in my database, and I can start publishing new updates to that. So if I go into my talk, into my test, which is where we are, and I start going, hey guys, shows up in the browser. So that's WebSockets in the background. Like there's nothing super fancy there, but this is the nicest WebSocket layer you're ever going to deal with. And you don't have to worry about anything. I'm just, do you have some data for me? Okay, give it to me. So now I want to, so that's a really simple way to use Firestore, right? Real-time listening. It's nothing super complicated. You could do it with an XHR. You could do it with a raw WebSocket. But I have this sort of crazier setup here. So I'm gonna, this is how you clean a collection. Delete all documents. Yes, no. Yes, please. Delete all my documents. So let's get back to here. I'm not actually going to go through the process of writing this because it took me like 4 hours today to write it. But my demo 2 over here has a bunch of code. We'll look at it a bit. But this goes through that process that we were looking at with the CRDT. So I originally wanted to do the prose mirror version of the world, but prose mirror is actually harder to write than writing this from scratch, which says something, but you know, there are reasons. So again, same basic setup, get my element, all that stuff. Same basic HTML, but all of a sudden I get some really nice things in here. So if I go over to my parcel and quit this one and switch over to my fancier one, parcel, and that's in demo2/next. Stand that guy up. And what this is doing, when we look at it, it's going to put a listener on key down, and I'm going to be able to type into a blank key element, which is not hard to do. Anyone who's ever written JavaScript event listeners knows how to do this. You can do it with text content areas, but you can also do it with bare JavaScript if you're really stupid. So I'm going to load up two browsers that are both hitting the same place. So they're both in the same state, and I want to make sure that you can see what's going on here. So these are now both listening to state changes. If I go over here, oh, that's not going right. So this is super fun. So my code is a little screwy. I knew that was going to happen, but anyway, I wanted to test it. So this is the fun part about this. Okay, so what that basically just did is a full conflict-free replicated data type update of the state of that text, and it's not rendering correctly from the beginning. That's the problem. So I'm not going to be able to show you full thing, but I'll show you the theoretics behind it, and you can appreciate my effort rather than my utter failure to do this right. And I think the problem is related to the timestamp field, but we'll look at that in a second. So what I'm doing is I'm pulling from the CRDT root, right? And I need to use that in a couple places, so I pull it. I use an await to get my first version of the state. So that's a thing that I was saying about like getting a checkpoint. This is a checkpoint. That's all really a checkpoint is. It's an initial get that is synchronous. And then once I do that, I push all of the states that I got. So remember how we had A and B, tigers and apes and cats and dogs? Well, this is all of them. So if I look at that collection in Firestore, if I can find it. So my, this guy has states in it now. And these are all the different states that I've just created by typing. So you can see they've got a bunch of stuff. Time indexes are fine, except they're not, because some of them are not a number. So, anyway, I didn't say it was perfect. But theoretically, if you got the time indexes right, this would work. But these states, so that the theory is that these states, I'm going to say at position 0, I have an A at this time index. At position B, I have an S at this time index. And like every state has that recorded, right? When did you set this? How did you set it? You know, and you can extend that model indefinitely. You can imagine all the different structure and sort of metadata you can put around that. But this is meant to be a simple example. So the working one here just has my text, my position. So I've indexed this data by position. And then my time index, which is just basically a way of saying, I have received this many items at this point in time. So in the code, that looks like this. So I get a state, and I do this reduction, right? So my reduction of a state is, give me a list of states, and for every single state, for every single key, I'm going to look for the one that either I don't know about already, or that has a later time index, right? So the last writer wins. Theory of the world is, if you wrote after I did, and we both know about all the same things, which is what time index is fundamentally saying, is I know about the same things as you did at the time you made this write, right? So if we both agree on those things, then I'm going to take your update. If we come into conflict, this is the interesting case. If the time index is the same for two different clients, then we have to come up with a rule. And this is where the conflict-free comes into play because your rule set is going to be different for your implementation. Like that Lambda Days talk that I pointed to, the guys were like, okay, so this is perfect, it's easy, it's super, here's all the things that work. And then they came up against this and they're like, oh yeah, so usually we just do an ordering like this, but sometimes those orderings are also the same. So then we do this. It gets into a lot of things. So for me, and the reason why you have that stupidly long, like if I reload that again, let's just glory in my failure here. The reason why that looks that way is because I am appending all of the data from the same time step. So all those characters are from the NAN time step, right? So that's why they all show up, because I'm just appending them. I said, if you edited and I edited at the same time, and they're not fundamentally incompatible, you're not doing complete, I'm not doing an add, then I'm just going to put them all in. Because that's really, having done it for 2 years, I've yet to come up with a better rule than we will insert all of the characters that everyone inserted.